Hello, welcome back to the channel. So this is a continuation video again. So we'll solve this example again in a different way because I also felt that the negative sign adjustment was a bit trickier part, and this video will also give you an idea that whenever you have questions like these, when you have to convert a sigma notation into a definite integral, there can be multiple correct answers, and we'll clearly see this thing in this video as well. We'll derive an answer in this case which would be completely different from the answer we got in the last video. And the reason why there can be multiple correct answers is because the definite integral is the area under the curve. So if you have two different definite integrals, but the area under the curve is the same for both those definite integrals, both of them will be the correct answers. So that is why you can have different multiple correct answers. And let's solve this question now. So we'll start with again comparing this sigma notation to the sigma notation that we have for a Riemann sum. And I can clearly see in this case as well that my delta x is 2 by n, right? And now I have to find my xi, and I know that my xi is a plus I delta x, which in this case would be a plus I 2 by n. And by simplifying it down again, it would become a plus 2i by n. And I can clearly see that I have a 2i by n term in this case. So now let's make things simple. Let me assume that my a is 0 in order to simplify my xi expression. So if I assume that my a is equal to 0, my xi would become 2i by n. And I also know my delta x is 2 by n, right? So let me write my sigma notation again. And my sigma notation in this case is limit n goes to infinity, sigma I varies from 1 to n, e to the power minus 1 minus 2i by n times 2 by n. And now let's do all the conversions again. I know I have to convert every occurrence of 2i by n and change it to x. I also know that I have to convert every occurrence of 2 by n and change it to dx. And I have to convert this expression to the definite integral expression. But the only thing that's missing is my right endpoint. So in order to calculate my right endpoint, I know that my delta x is equal to b minus a over n, and my delta x is 2 by n in this case. And since I have assumed my a to be 0, so my b would be, so b minus a would become b by n would be equated to 2 by n. So this gives me that my b is equal to 2. So now I've got my right endpoint, I've got my left endpoint, and I have everything sorted out. So now let me move this b equals to over here. So I have everything in place. And let me erase this, and now let's calculate the final answer. So now I know I have to change my every occurrence of 2 by n to dx. So let me write dx in this case. This expression will be changed to a definite integral expression. So it would become the definite integral sign with the endpoints 0 to 2. Right? And I also know that I have to change every occurrence of 2i by n to x. So in this case, it would become e to the power minus I minus, since my 2i by n is x, so I'll write e to the power minus 1 minus x. And this is my final answer. And this is indeed the correct answer. And this is indeed one of the multiple correct answers that I was talking about at the start of the video. And you can clearly see that the answer over here is completely different from the answer that we calculated in this case. And both of these answers are correct. So it doesn't matter which approach you follow in order to solve this question, because both of these approaches are indeed correct. If you found the solution in the last video to be easier than this one, you can always follow the approach that we discussed in the last video. But if you found this video to be easier than the last video, you can follow this approach. And you'll get full marks for both of these approaches. So you don't have to worry about any approach. So that was it for today's video. I hope you found this video easier than the previous one. I personally also found this approach much easier than the previous video's approach. So feel free to follow whichever approach you like. Please follow the channel in order to get notified about the other videos that I'll be uploading. Also, feel free to comment down in this video if you have any doubts related to this video or any doubts in general as well. Thank you so much for watching. Bye bye.